Hello guys, and welcome to Bradio Software Development. My name is Brad, and today we're going to be carrying on with my microservices series, talking about Mongo databases and connecting them up to our microservices. Now, before I start, I'm just going to apologise for not having a camera. I'm having some technical difficulties with it, and it's not currently working. So you're going to have to do with the screen as it is for now. So without further ado, let's get straight into the terminals. So just to recap our memories from the last episode, we talked about our stock system microservice infrastructure, where we had an online orders microservice, a stock service, and a delivery service, and how they connect together and talk between them. And we created a few methods and managed to get an order firing to the other event and getting picked up. The next thing we need to do is actually store some kind of database. There's two different approaches to this. So you can either have one database that covers every single microservice that all of them connect to, or you can create multiple databases, one database per microservice. Obviously, I prefer option B because it gives us our own database and our own microservices. And if you do eventually break out into multiple teams in the future, then your microservice team will be in charge of its own database and its own data store. Then they're also in charge of updating that accordingly when they want to save and persist data from other services. So I think we're going to go with that approach for now. So if we just draw this out, so the thing to remember is that if you were to merge all of these databases together, then you would have a structure that you could probably use on a single database. But the idea of having them separately is so that you separate the concerns of each microservice so it has its own data. So essentially there will be a stock database, there might be a collection of stock, and in here it will list the amount of Jaffa cakes that is in the stock system. Down here you have delivery, and you might have a delivery record that stores the address information and maybe the payment information for the customer, and when that's going to get delivered, what time, what date, whether or not it was returned, etc. And then over here you've got the online orders database, and that would store information such as when the customer made the order, what time they were logged on, maybe what IP address they came from, what payment method they used. So as you can see, there's already a little bit of crossover between the delivery and the online orders, because you might want to store payment information in both. If this was a more advanced system, I would probably end up creating another microservice specifically for payment providers and payments and receipts and things like that. But in our system, we've just got these three. We're not going to worry about payments. I think last episode we said that everything's free. So you can have as many Jaffa cakes as you want as long as there's a stock and demand for it. So the first thing we need to do is actually start up the rabbitmq service. So let's do a cd into, we're going to use our top terminal, and we're going to cd into scripts, and then we're going to run our rabbitmq startup script. Okay, so now that's started, we now need to think of our Mongo database. So all we really need is one Docker Hub image running with one instance, and we can add multiple databases to that, and then in each database we can store multiple collections. So let's go ahead and do that now. Open up your browser and go to Docker Hub, search for Mongo, and let's spin up a basic Mongo instance. Okay, so we actually need to copy this and then change the tag to latest. And now we should have a Docker image. We can use Portainer to check this. So if we log into Portainer, go to our containers. As you can see here, our MongoDB doesn't have a port assigned to it, so we need to go ahead and do that now. So let's stop this image and remove it. And we'll add the port for Mongo. It's normally on 27017, so we'll just use that one for now. And as you can see here, we have a Mongo port exposed. So I normally use robo3t for these kind of things. So let's open up robo3t. And I'm going to connect to our local Mongo database. And as you can see here, we're now connected to a database. So now the next thing we need to do is actually set this up in NestJS. So if we go back to our code editor, and we'll start off with the first microservices, which is stock A. And we will configure this in the module. So I've actually forgotten how to do this, but if we go to the NestJS documentation, Okay, so the first thing we need to do is install this package. Now, because we're using a mono repo, we can install it to all 3 microservices at once. And now we also need to create a database provider for this connection. So if we copy all of this and make a new file in source called ms-a-stock.database.provider.ts, and we can paste that into there. So this will need to change to stock, and we'll also add the port here as well. If we go back to the documentation, we now need to add the provider to our providers object and our exports object in the module. So we don't actually need to add it to an export because we don't use this module in anywhere else. So we can just have it in the providers. We don't need to put it in anything else like exports or imports. So we can leave it as that. So now if we actually run this app, npm run start dev ms-a -stock, we should get some errors or some success messages on a successful database connection. So as you can see here, we're getting some errors. It failed to connect to the server on 27019, and that might be because we're actually mapping it to 27017. So we come over here and we change this to 27017 and save that. It should auto reload and connect. There we go. So that's our Mongo connection done for stock, and we need to do the same for delivery and orders. Okay, so once all of that's set up, we should be able to start the other microservices. There we go. So now we need to think about exactly how we're going to define these objects. So in stock, we're going to create a new folder called schemas. And we're going to create a new file, and we're going to call it stock.schema.ts. And if we go back to the documentation, we can copy this code here, which is the cat schema, and we can paste it into here. And then all we have to do is rename all of this. So this will be stock schema, and it will have a quantity, which is a number. It will have a name, which is a string. What you really want to do is, when you have a record that spans across many different databases, you kind of want to have a unique identifier that is separate from an object ID, because object IDs are only unique to the database that it's sitting on. So what I like to do is use something called maybe like a GUID, or have like a common unique naming convention that you can decide upon yourself. So what I'm going to do here is I'm going to actually have stock ID, and I'm going to put it as a string, but this will essentially be a GUID that's auto generated every time that we've got a new stock item. And in classic NestJS, along with a schema, you also need an interface so that you can use that within your code. Remember, the schema just maps to the object in Mongo. You also need an interface as well. So let's create a new folder called interfaces, and let's create a new file called stock.interface.ts. And if we go over to our documentation, we can just copy this from the documentation, the cat interface, and paste that. And then we can change these accordingly. So if we grab our stock schema and put it into the bottom window down here, so it makes it a bit easier to read, we need to change interface to stock, and we have stock ID, which is a string. We have quantity, which is a number, and then we have name, which is a string. Okay, and if you also notice as well, it extends document. So there may also be other fields on here like ID, version, created at, updated at, and they will be on the document object. So we're just extending that interface here. So the next thing we now need to do is to maybe try and actually store some of this data. So yeah, so if we go to our microservices tester that we have here, where we can hit curl requests, we need to create a couple of extra methods for things like creating stock and creating deliveries, like sort of almost like back-end services, just so we can test it. So if we create a couple more here, so we're going to need create order. Sorry, no, we've already got create order, so we're going to need create stock. And we'll call this create stock. Create stock. And if we look at our schema or our interface for stock, we have stock ID, quantity, and name. So we need to make sure that we capture those. So we've got, let's just drag this interface to the bottom of our pane, so we have it all in the same window. And we need to create stock ID, which would be a GUID. So there's a really nice library for this called UUID. So we're going to go ahead and install that. In the bottom right-hand window, we're going to do npm I -- save UUID. And at the top of our file, we're going to do import star as import UUID import. I think we need to change the star to v4 and put it in angle brackets. Okay, so we've imported that now, and the way to use it is literally just to do UUID and then put a bracket, and that'll create UUID. The second thing we'll also need is the quantity, so we'll put in maybe 5 for now, and our name will be Jaffa Cake. So this will be a name that could be read by humans. It doesn't have to have slashes or dashes or underscores in it, so we'll just call it Jaffa Cake with a space. And then we also need to create our function in our service. So we go over to our service and we'll create a create stock function. So async create stock. So we've got UUID, comma, quantity, comma, name. And then we'll copy this code from above and we'll paste that. And this needs to go to our stock database via a stock route. And the data that we're sending is basically all of this data here. So we'll copy that into there, and then we'll put it on the console log as well, just so we know what's going on. Okay, so now we've got our create stock controller and service. We now need to add a receiver to the microservice that's listening for this. So we're going to create a new window, yet another window. I know, it's getting pretty crazy now with all these windows on the side. And we're going to start our test application. So npm run start dev, just microservices on its own. Okay, and I think this is running on port. What port is this running on? 3000. On our bottom window, curl http :// localhost localhost 3000 :3000 for the port / and then here we have create -stock. So when I press enter, you should see some stuff happen in the top terminals. There we go, that worked. So now we've got our message being published, and if we look at our top window, we can see that it's been received successfully from the stock service. So now if we open up our stock service over here, we now need to basically add some code in order to store this payload into our database. So let's go ahead and check out the Nest documentation again. Okay, and if we look at our cat service here, we need to add an injector for the cat model. So we'll copy that injector from the constructor. We'll go to our service and we will create that in our constructor. And make sure you import the relevant packages using quick fix. It's very handy, that. And model. And then cat would actually be stock. Make sure you import it as well from our stock interface, because remember, even though it's a mongoose model, it is a type of stock, and this stock extends document. So if we go into our interface, you can see that we extend the document there. So that is correct. And we also need to rename this to stock model. And rename this to stock model. Okay, so we have a problem here. We need to actually export our stock model. So if we go to the documentation again, we can see that we have a provider for each schema. So in addition to a database provider, you also need a model provider, and we'll put this into a new file. Now we can add multiple providers into this file now. We don't need to just add the cat one. So we can take out cat, replace this with stock model. A model will be called stock, and it will come to our stock schema to model, and then go back to your module and import it. There we go. So now that should work. I should fix our problems on the right. So we scroll down. And there we go. Everything seems to have been fixed. So now we need to work out whether the message is actually related to the creation of a stock item. Now, there's a few ways we can do this, but what I am probably going to do is go back to our tester and our service. We need to tell the receiver exactly what this is that's coming in. So we know it's related to stock. We know it's on the stock route, but what exactly is it? What exactly is this? Is it a creation event? Is it an update event? Is it a delete event? So what we need to do is add something in addition to data. Now, there's many different ways that you can do this. I'm just going to shoehorn it in because that's how I roll. And I'm going to add a method here called type. And I'm going to put create in there. So it's going to be a create event, create stock event. And I'm also going to make sure that I log that as well. Okay. And that should get around the problem. So if we now save that, go to our terminal window at the bottom and hit the curl request for create stock again, we'll now see that we've got a type create stock. Now we can use that as a definer to work out what we need to do with the payload. So now if we go to microservice a stock service, in here we can do a switch statement. There's many different ways you can do this as well, bear in mind. And we can do message.type. We can have a default action, which we won't have any. Okay, I need to change this to any because it's throwing up some errors in my code. And our case will be create underscore stock. And instead of having everything in one function, we'll just make it call another function. So we'll do this dot handle create stock, or let's just do create stock actually, and then we'll pass through the message dot data. Okay, and underneath here we'll do a public async. Really all of these methods should be private actually, but we'll keep them as public for now. And we'll do create stock. Now we need to actually do something with this data. So this is where the database connection comes in up here with the stock model. This is a direct mapping to our database internally. So what we can do is do await or return await this dot stock model dot save. No, we need to pass through the data for it. So I think this takes a parameter of the fields. So this would be data, and then we can do dot save. Is that right? We need to create a new instance of this as well. So we're going to do return away new this dot stock model data and save. Now you can do a whole bunch of logic around this to determine whether or not this data is going to be safe to insert directly, but for test purposes I know that this is going to be good for the schema, so we're just going to assume that all the payloads actually match the schemas that we have, and then nothing can go wrong. So it's a bad assumption, but we are creating this as a test scenario, so we don't need to worry. So now just to confirm that all this is going to work, if we connect back to our database, we can see that we have absolutely nothing in here. And then when we hit the curl request on the bottom right terminal, it will now pick it up on this service, which is the stock service. And if we refresh our database, voila, we now have a collection in the database called stock. We have a collection called stocks, and in here we should have one object with stock ID, quantity, and name. There we go. So that's one event being saved into our MongoDB database for stock. So now all we have to do is do exactly the same thing for creating an order and creating a delivery. But I think we'll take that into the next video, because now that we've discussed the very basics of receiving a message and storing it in a database, we can then take it a little bit further in our next video, and we can talk about how we actually pass this data around when we want to, I don't know, maybe when the customer makes an order, we want to be able to -1 off the quantity in the stock system and add that to the customer temporarily. And then we need to talk about how messages get passed around between databases. We need to talk about how messages get passed around from database A to database B. So we'll talk about that in the next video, because I think we've done quite a lot this episode. So thanks for watching. Remember to like, comment and subscribe. I hate saying that, but please do it, because it really helps out the channel. I'm aiming to get to 1,000 subscribers by September. I don't know if it's achievable or not. Apparently on Social Blade it expects me to get to that by next year, but that's just not good enough for me. So I want to do it by September, and like, comment and subscribing will massively help me. I know a lot of people have already asked for MongoDB videos, so I'm going to be doing a few of those in the future. So again, thanks for watching, and I'll catch you in the next video. See you later. Radical, emphatic, beat addict in the stab hit. I envelope the game, call me Rabbit. Hop to hop, I run the internet equivocally. Bitch, I be hit him with the bite style symmetry. Digital gangsta reppin' till I'm dead. Steady grip Apache logs when I'm looking for the feds. Fast forward, now the internet anonymous and captains of the lows